Yesterday when we left off, we left off with the empirical rule, kind of showed you that again. So we're going to use that today, and then we're going to use our calculator. We'll finish up topic 4 today, and then be thinking about this. If you have something that you want me to go, hey, I want to see another problem with that, or whatever, I can pull that, we can look at that here in a second as well, okay? And so that's what I'll do with you guys tomorrow, all right? I'm gonna leave it open to you, so you bring questions that, hey, I need you to see another one of these type problems, or whatever, okay? Because I won't see you guys on, I won't see you guys Thursday, obviously, because y'all be taking this test or whatever. Friday afternoon, there is no plans, so, but we'll do that. All right, here we go. On this one, it says that this is a non-calculated problem. This is the one on the right on that page. It says let x be normally distributed with a mean of 100 and a standard deviation of 5. And so if I had this would be 100 there. All right. Standard deviation of 5 would make that 105. That would make it 95. What's the probability between 95 and a 105? 68%. Yeah. So 68% or 0.68 would be the probability, okay? If I did a second standard deviation, I would be at 110 and I'd be at 90. What's the probability of being between 90 and 110? 95%, okay? Now, it's not asking those questions, but I'm just kind of using this as review. So on this, it says on the diagram, shade the region representing x is greater than 105. Well, obviously, 100 is in the middle, 105 would be on the right side, and greater than 105 would look like this. As long as your line is on the right of the middle point, and you shade to the right, you would have gotten credit for that. Okay? Given that the probability that x is less than d is equal to the probability that x is greater than 105, find the value of d. 95, because this graph is symmetrical, correct? So what it's saying is this. By the way, could you find me the probability that I'm greater than 105? Could you find this probability right there?
Yes.
It would be
16%.
16%. Everything to the right of 100 is 50. We said this was 68, so 34 and 34. So what's it take to get to 50? Would be the 16, all right? So if that's 16, then I want the side over here that is also 16, which they're gonna be nice and symmetrical graphs, so it would have been 95, but it would have been the same spot, okay? Now, it says here, given that, we've already kind of determined that this is true, given that that's bigger than, that the probability x is bigger than 105 is 16. Correct the two significant figures, find the probability between d and 105. So what's this probability right here? We've already hit on it, we've already talked about it. It'd be 68%. Okay, or 0.68. Good on that one?
Would they want any work for that?
There's not a whole lot of work. There's only worth 2 marks. If your 2 marks are below, a lot of time you're okay without showing work. Okay? Once it gets into the level of 3 or more, then we need, now, I'm still gonna show it if I can, but you're right, that's a little bit harder to show there. I think my picture would probably be a better way to show that more than anything. I might have drawn a picture down at the bottom. Okay? I'm gonna turn the page and we're gonna do the one on the next page. I'm gonna leave that one on the left for the end. Give you a chance to look at this one on the next page.
Does this use calculator?
Is it right at the top? Is it SP2? SP2 is a set calculator. Yeah, I'm pretty sure it is. This is a question number 6, so it's a little bit higher level problem, although there doesn't look to seem like there's a whole lot of information here. All right. What's one thing that they left out of this one that I was a little disappointed that they left it out?
The standard deviation.
Yeah. most of the time with these, I want the mean and the standard deviation. If I have those two things, then these problems are not hard, okay? Now, if I look here, 25 is my mean. They're using some random 27, and so between 25 and 27, it says this area is 30% or 0.3. It says find probability that I'm bigger than 27. So find this. That would be
320.
20%.
Would 0.2 be okay, or does it have to be 20%?
Either one of those two. All right? But 20 is not okay.
Yeah.
You gotta put 20 with the percent, then that's good, but you've gotta use one of those two ways there, okay? Now, so it asked me to go find the standard deviation. Anytime that I'm asked to find the standard deviation, most likely I'm gonna be using my z-score formula. Good news, it's on my formula page, okay? So this one's on the formula page. So this is the z-score here. Z-score means how many standard deviations above or how many standard deviations below. So it's a negative z-score, it would be below the mean, positive above the mean. This is my mean right there. So if I were to plug into this problem, 25 would go there. So I'm gonna go minus 25. The other number in question in the problem is 27. That's what X is representing. I know by reading the question, it says that I don't have this one. I don't have the standard deviation. So they must have given me a way to find the z-score. Okay? When we find the z-score, what we're looking at is we're standardizing the data. So we're putting all the data on the same scale. A mean of 0 and a standard deviation of 1. All right? And so if I were to do that, they have actually given me the area. They've given me the area of 27. So what's the area of 27? 0.2 is above 27, and how much is below 27? 0.8. So 27 is like the 80th percentile, so to speak, okay? So I'm better than 80%, I'm worse than 20%. Okay. So they've given me the area. So I'm gonna go to my calculator. This is where I'm gonna have to go use that. I'm gonna start over here on new, and I'm gonna go to just my normal calculator. This is normal distribution. There's two locations I can find it. I can find that in probability or statistics, either of those two menus. I'm going to distribution. Now here's the difference. When I use normal CDF, I know the mean, the standard deviation, and I know the boundaries, okay? That's what it's gonna ask for. Well, I can't use normal CDF right now because I don't know the standard deviation, all right? So I'm gonna use inverse normal. When I go to inverse normal, it's gonna ask me for the area. What area do I have? I have 0.8, also I have 0.2. One's right, one's incorrect. We always wanna use the left area, okay? If you use the right area, you're gonna get the same answer, but it's gonna be negative versus positive, okay? So if you think about it, you're probably okay, just as long as you understand what the negatives and the positives mean. Just don't take them at face value. You're going, well, you don't have the standard deviation, how could you do this one? But we're standardizing it, so we're making everything zeros and ones, that's what we want. So 0.8 is what the value I'm gonna use. I hit okay, so that is my z-score. Yes?
So does this mean that for a normal distribution with a mean of 0 and a standard deviation of 1, the total area is 1?
It means that the total area under the whole curve is 1.
Yeah. Okay.
Okay? But what this is meaning is that the z-score for 27, so if I were to say 25 is my 0, all right? And I'd say 27, how does 27 relate? It would have a z-score of this, so it would be a little bit lower than 1 standard deviation. That's what this is saying, okay? So I'm gonna go put that in my calculator, or in my formula, excuse me. Yep. So 0.8416. Now if you were gonna solve this, I'd multiply by the standard deviation. I'll multiply by the standard deviation. This is 2. So essentially what we're doing is we're gonna take 2 and we're gonna divide it by the 0.8416 that we have. Okay. So in my calculator, I can go back over here. 2 divided by that, there's my standard deviation. So if I was rounding two significant figures, I'd say it was 2.38 is what I'd say. Now, here's the good news and bad news about that. They made me find out, but now if once I had that, I could solve anything that you ask. Now it gets easy once I have the standard deviation. Okay. All right, let's flip back to the first page. We have one problem left in this packet. Give you a chance, see if you can find A. I might draw a picture for that. It's an extremely similar problem to what we just did, okay? So I have this, again, the problem is I don't have the standard deviation, but they asked for that right away. Here's kind of a picture of what's going on. At my mean of 21, I have the other number that's in question here, 23.7, I'm going less than it. And there's 8% they're less. So hopefully you set up this formula right here. Again, that's off the formula page. So if I did that, the X is 23.7, the mean is 21. I don't know my standard deviation, and what Z-score did you find? The same one we just did, because what did you notice? It's the same area, correct? So the area is 0.84, or the Z-score is 0.8416. Gonna multiply again like I did. So I'm multiply by the standard deviation. This difference right there is 2.7. Then I'm gonna divide by 0.8416. Anybody come up with that standard deviation? 1, is that right? 3.21? There's standard deviation. I don't like this problem because normally they might say, it's hard to say, show that the standard deviation is that, but really, like, you might miss the problem if you didn't know that the rest of the way, correct? Because I think you need it for the next step.
Where did you get that 0.84?
That's how the calculator, I went and I said, the area that I have, I go menu, and I go statistics or probability distributions. I'm gonna use my inverse normal. The area that they've given me is 0.8, that's the area on the left.
Okay.
And then I'm standardizing it, so I'm gonna do the 0 and the 1s. And so that is my Z-score, that's what that is. Okay, good. Now, if I keep going, students chosen at random, the student has the same probability of having a score less than 25.4 as having a score greater than whatever. Find the probability that a student has a score less than 25.4. alright? What's the probability to have a score less than 25.4? So 25.4 would be there, and I want all that value that way. So now, I'm gonna go use my other normal distribution in the calculator. So I'm gonna use the normal CDF. The lower bound, negative infinity, is that correct? Yeah, that stays good. So I'm going, everything less than the upper bound was 25.4, is that correct? My mean was 21, and now I can do this problem because I know the standard deviation. By the way, this is what concerns me about this one. If you didn't get the standard deviation, make something up and show that you plugged it in, all right? And you might get some partial credit on that. So there's the standard deviation that we found. Hit enter, and I get 0.915. So like 91.5%. Is that one? However, you still could have gotten this one right if you didn't get that correct. What's the value of that? Anybody got a thought?
You just subtract it from the mean and you get the negative.
How far away from the mean is that? 4.4? So if I'm less than and it's 91%, if I'm greater than it's 91 point, it's ought to be here. And so these ought to be equal distances from the mean. So whatever 21 minus 4.4 is 16.6. I still could have gotten that one right, understanding the symmetry of that problem. Okay?
Wait, what'd you subtract?
I used 21. 21 was my mean. How far is 21 from the 25.4? So that's a difference of 4.4. So I gotta go 4.4 this way, so subtract it from 21. Because it's nice and symmetric. Come. Alright. I will collect that from you later. I'm not worried about it. I may collect it Friday afternoon or something like that, or whatever, because we won't be doing anything. Questions that you have? Let's do another one of these. I need to see another one of these.
Can we have another triangle problem using the log cosines and log
Okay.
cosine?
Doing that at paper too. All right. That would probably be on a paper 2. Let me see if I can find that real quick. All right, let's see if it's one of these. Triangle. Oh, I remember that one. Let's do this one. Let's try this one. Give a chance to look at this. I think this is kind of what you're talking about. I know when I look at this right here, one of the things that we see, you were asking about like law signs, law cosines and stuff like that, and I'm pretty sure I'm gonna have to do that for part B. Let's look at part A first. So it says find AV, so it's asking me to find that side length right there. Okay? Again, this is kind of where we were the other day. It says find that. They're asking to find the distance of that is what they're asking. So how far is it from A to B? Well, they give me point B has these coordinates, point A has these coordinates. So I'm going to use the distance formula, okay? But this distance formula is going to be, what did we call it? What did you call it the other day?
The imaginary triangle?
Yeah. All right. And so, I knew you're laughing a little there because I couldn't remember. So 1 minus -1. 5 minus 1, and 0 minus 6. Now, if it's 3 dimensions, you just do all 3. Okay? So 1 minus 1 would be 2, so squaring that would be 4. 5 minus 1 would be 4, square that would be 16. And then that right there would be 6, that'd be 36. So it'd be 40, that'd be 56. That would be my non-calculator answer, but you could type that in the calculator and get that answer. That would be fine as well. That would be roughly 7.5 or so. Now, the next part, given that the area, or excuse me, the angle is 40, so AVB, so this angle right there is 40, then find AB. So how do we do that?
Well, we actually can just use trade, can't we? Because we have the, or no, we can't.
It's not necessarily a right triangle, correct?
Yeah.
Because what are we asking? It's asking for the face of this one right here, right? And so I know this side length right there, that's the square root of 56. I also know that side length, it is the square root of 56. So this is a side angle side triangle. So I'm going to do my law of cosines. So I'm going to say x squared equals 56 squared plus 56 square root of 56 squared minus 2 times square root of 56 times square root of 56 times cosine of 40. That doesn't look too awful because the squares and square roots cancel. So that's 56, that's 56. This gets a little bit tricky over here. That's 56 times -2 cosine. I can do that, or I can just plug it all in the calculator and fine. Make sure that you're in degrees. Good on that one? So you see how they're using the geometry through this too to help get to that. That's why this was question 7 or so. It was later. Yeah, it's question 7. So there could be another way that they do that. Keep going, or are you good?
What's like the law of cosines again?
Law of cosines is sine of A over A, sine of B over B, sine of C over C. And they're all equal to each other.
Wait, isn't that law of sine?
Oh, law of cosines. Oh, law of cosines is basically Pythagorean theorem. Okay? So it's c squared equals a squared plus b squared, so that's Pythagorean theorem, minus 2ab cosine of c. So it's got that extra piece on there, right there.
Oh,
It is on your follow-up page, though.
okay, cool. Yeah, I'm good.
Okay? Any others? We finish that one, we'll go to another one. Is there any other type of question that you want to see?
Could we look at another that deals with like the laws of cosines and stuff?
You want to do more of these?
Yeah. I don't know, I feel like that's hardest for me.
All right, let me see if I can find another one. Specifically that, or just any trig?
Really, any, I don't know.
I mean,
But especially that, but whatever.
okay. Let me see if I can find another one real quick. Let me go back to 2021. So you can find one here. I might be able to find one here. Most of the ones that you're asking about are normally fall on the calculator page.
I mean, if you can't find one, that's fine.
Here's one that uses it a little bit. Let me get rid of some of this. All right, here's another one of those type problems. All right, I'll give you a chance to kind of look at it, kind of read it, then we'll talk. It's not a prize winning goat this time, it's just a horse that's stacked up post. So I know it's a little bit depressing. Okay? Alright, so we got two straight fences meet at point A. Alright, horse tied to post P by a length of R. Point D is on one fence and point E is on the other fence, such that PD equals PE, which equals PA. Alright, so which equals R. So this is R, that's R, that's R, that's R, alright? And DPE is in theta, right there. So they did a pretty good job showing. The length of arc DE shown in the problem is 28, alright? Write an expression for R in terms of theta. How do we find arc length?
It equals radius times the angle.
Or you do the circumference of the circle times the person.
Yeah, you could do all that as well.
Circle.
Alright, there's what they're looking for. Alright, now, it says write down an expression for R in terms of theta, so I wanna solve for R. So R would equal to 28 over theta. Okay? Show that the area of the field that the horse can reach is that. Okay? So the horse can reach this area here and they can reach this area here, correct? So can you find the area of basically a sector and a triangle together, correct? So a sector, the area of sector is 1/2 R squared theta, okay? How do I find the area of a triangle? You could do base times height, but base times height is gonna be hard to find in that one. This is the formula that I have. But I don't have any angles in that one, correct?
Oh, you do.
I
because
do.
You have the 180 minus theta.
Very nice. That's what they're looking at. I have this angle here. I know that angle right there, it's its supplement. It makes a linear pair. So this angle right here is 180 minus theta.
And you know that, the other two angles are equal.
Mm-hmm. Yeah, these are equal as well, correct. Yep. And so A and B are both R squared. So I have that right there. So I need to add this area here and this area here is what I need to do. That's the area of the sector, that's the area of that. Now, when I add that, what's kind of nice about that? I can have, if I plug in R, I can have one variable. So here's my R right here, correct? Right. Now, you might, before I plug in R, I might do this. Just a thought. You don't have to do this. So that I only have to plug in R once. This has a half, that has a half, I'm gonna factor it out. That has R squared, that has R squared, I'm gonna factor it out. So I would have 1/2 R squared, I'd have a theta left, and I'd have plus sine of 180 minus theta left. By the way, kinda looks close there. Alright? Kinda getting on that idea. So on this, you're right, I'm gonna go 1/2, and then I'll plug the R in, so I'm gonna go 28 theta squared. 28 squared? Anyone? Anyone?
What'd you say?
It's
784.
784, then cut it in half. She's using her cheat sheet on there. So this put together is that 392 over theta squared, so that works out well. But here's the piece right here that we've got to talk about. How do I get that to be here? How's that going on there? See the theta plus this right here.
Wow, they've done it again, they've confused us. Please stop. They've done it again. Oh, I don't like it whenever this happens. This happens kind of often to us.
I was just taking tests, I
You
write
can
that
make it
down, and then I
180
write the
tomorrow.
final answer down, and just hope that they
You
assume
would,
that I
you
know
would,
it.
if you did some of this, you'd be pretty good. You just have to make this last move. What's this? How do I get this to be sine of theta? Is what I gotta get.
Whoa, can't, is it possible to factor?
Do you just, sine of 180 minus sine of
sine of theta, sine of 180 minus theta.
Oh, it's the reference angle.
It's the same exact thing. Correct?
Yeah,
Okay?
so it's.
If we draw that shape on the test, are they gonna understand what we mean by this?
I think that would be a good thing, yeah. And so that's what's going on there. So it's the sine of the acute and the sine of the obtuse is basically what we're doing. They're the same thing, kind of deal. And so, this right here is the same sign as this one right here. So I can simplify that to theta plus sine of theta. So sine of theta and sine of 180 minus theta are the same exact thing. So that's what's going on. So that's kind of going back to some of those things. That's where it's kind of tricky. You just kind of got to go back to your Fulmish trust as you're going.
That's what I started doing when I got to some point.
I think we're good for the day. Unless somebody wants
Yes,
more.
I'm done.
I thought you were saying yes.
No.